Okay. Good evening, everyone. My name is Dr. Sam Owusu-Ababio. Usually, Dr. Chow is the one who leads this program, but he stepped aside today for me to step in just for a moment. I would like to welcome all of you to our third presentation in our fall seminar series. And I would like to introduce our speaker, for this event. He is in the person of Jake Brunoller. Naylor, okay. He is a graduate with a BS in civil engineering from Valparaiso University and is a registered professional engineer in Wisconsin. He previously worked as a project engineer for Patrick Engineering, and then as a project manager for the Norfolk Southern Railway Corporation. Currently, Jake is the regional engineer for Advanced Drainage Systems Incorporated, supporting the Wisconsin and Upper Michigan sales teams as a technical specialist in stormwater modeling, manufacturing specification, structural design, best construction and inspection practices, and more. Currently, Jake is the president-elect for the Southeast Wisconsin branch of ASCE.
Oh, I took office last week. I should have said that.
Oh, you took that off?
I did take office. I'm now current president.
Okay, he's not the current president. He previously served as the branch director at large, overseeing membership and several conference and event coordination. At the section level, Jake was also invited in the drafting and publication of the 2020 ASCE Wisconsin Infrastructure Report Card. In his spare time, he enjoys home brewing, woodworking, and travels with his wife as members of a traditional Irish band. Join me in welcoming Jake.
Well, thank you very much, Professor, for that introduction. That, as I said, that takes most of what I was going to say in that first slide. I forgot I'd sent you that. So that's awesome. So as he said, my name is Jake Brunoller. I live in Appleton now. I lived in Milwaukee for about 10 years prior to that, but I originally grew up in East Central Indiana. So silly Hoosier moved to the dairy state despite the fact that I have a dairy allergy. So I live here in Wisconsin and never eaten a cheese curd in my life. So, but appreciate the chance to chat with all of you today. Looks like mostly students here. I got my degree from Valparaiso University. I saw the concrete canoes outside. That's awesome. I was definitely on my concrete canoe team twice. We broke our boat in transit. So it was small fun memories / not so fun memories. I walked into the building. So appreciate the chance to be here. And so I graduated from Valpo 2008. My first industry position was Norfolk Southern because that's the only job offer I got. That's what happens when you graduate in 2008. You take whatever you can get. So for all you graduating with 3 job offers, I hate everyone. So upon graduation, I went to work for a railroad company and then entered the transportation sector when I moved to Wisconsin. So I was a transportation consultant for about 5 years. I've now been with ADS in the stormwater sector, which was the last thing I thought I would do when I left college. I was like, oh man, environmental, not nearly smart enough for that. So now I'm a regional engineer for ADS, which is actually a manufacturer. So with that, we'll get into a little bit of what ADS does. So I meant it. Oh, it really doesn't want to go. There we go. So ADS. ADS here in Wisconsin. So my company that I work for is the world's largest thermoplastic pipes manufacturer. So along with that, we have a suite of multiple different products and lines. So and so I would be remiss not to, even though I'm going to give more of a technical presentation, not going to go through every single product that ADS makes. That's a lot in one presentation. It would take the better part of a day to do that. But I'd be remiss not to tout some of our key values and associated accomplishments that really give me a reason to get up as an engineer and do what I do every day for ADS. So we are the largest producer of corrugated thermoplastic pipe in business since the 60s. We are the second largest purchaser of post-consumer plastics. And so it really means a lot to me that we consume over 500 million pounds a year of post-consumer plastics. So If you can actually get your soda bottle, your detergent jug, your milk jug out to the curb, it's got a 1 in 4 chance of ending up back in a product that ADS makes. So we just purchased that much of it. And then we take it to our plants, we clean it, shred it, and then dry it back, and then repelletize it, and then we send it through our extruders to make pipe. So and last personal photo and anecdote. This photo is from a seminar that was held before the pandemic. So back in the days when we didn't have to wear masks for meetings. But that's me if you look, you can see the doors of that car. That is a film used DeLorean. So as part of a stormwater seminar, I got to sit in a DeLorean that had been restored to factory originals. So the flux capacitor had been removed from it. But got to that. So that if you ever get a chance, that we hosted that seminar at the Automobile Gallery in Green Bay. And so a very eccentric business owner and inventor had that spot for us. So, but enough about me. What are we here to talk about today? So we're here to talk about urban stormwater, and we're going to talk specifically about ponds. Ponds, whether that be wet ponds, dry ponds. I'll speak to what I work on a daily basis, and we're actually going to talk about how to bury the pond. So when it comes down to it, we're going to bury the pond, just because, and not only how to bury the pond, but why we would bury the pond. And so the New Jersey Department of Environmental Protection, I'm going to look at the notes here, for the definition of a wet pond, according to the New Jersey Department of Environmental Protection, New Jersey DEP. A wet pond is a stormwater facility constructed through filling and or excavation that provides both permanent and temporary storage of stormwater runoff. So not really the words I probably would have chosen, but that kind of illustrates a point about stormwater as well. And about this presentation is folks don't always agree about stormwater topics, about stormwater issues, and about stormwater solutions. There's so many regional factors and variability that can influence, and associated data interpretations that make it very difficult to come to industry-wide consensus, even just on the definition of what a pond is. I'm going to present on some ideas and some solutions that may not be the perfect fit for every project everywhere. But nonetheless, it's why it's important to have a diversified array of solutions and perspectives in your stormwater arsenal, in the way that you think about how we manage stormwater. So today is really just it's to get you to think perhaps maybe a little bit differently about conventional stormwater design, and some ways we might be able to learn and think differently about how we execute that stewardship, how we manage our runoff, and of our world's most precious resource, and that's water. So right here on the screen, for those that can see it, picture it as an absolutely serene. It's perfect. It's ideal. This is what a wet pond would look like. So that's, I think, Southeast Wisconsin. I stole that off the DNR website. Pete Wood took that. I know Pete Wood from the DNR real well. I work with him all the time. So he took that. That's down in Caledonia. And so this is taken at its peak of serenity. So the pond is fairly clean looking, it's well maintained. Shoot, they even have it looks like some wildflowers, and the cherry on top, there's an American flag. I mean, how American can you get? It's beautiful. So who wouldn't mind? Who wouldn't want that out right outside on their property as they're going about their day-to-day business? Look outside at this beautiful, pristine pond. So who wouldn't? So when it comes to, and I show this on the screen right here, for those who don't know who that is, that's Dr. Wallace J. Nichols, a PhD in neuroscience, a graduate from DePauw University in Indiana. But he's been called the keeper of the seas by GQ magazine. Outside magazine calls him a visionary, a water warrior by Aquatics International, a friend of the sea by Experience Life magazine, and godfather of the water by Irish Life Health and Santa Cruz Waves magazine. So kind of he made the cover of GQ maybe about 10 years ago. He was one of the first ones to attach a tracker to a sea turtle and tracked it and published up this turtle's journey across the Pacific on the, what's that jet stream going across the Pacific. So the turtle, so basically everyone could follow this turtle's journey on the web. He was one of the first ones to do that. So really a water awareness. But Wallace J. Nichols, he's the world's foremost authority on the mental health benefits of spending time near, in, on, or underwater. He basically did research where he strapped an EKG to his, onto his head and then jumped in the water. And so he, what the marine biologist and doctor in neuroscience calls the blue mind state. So he's all about blue mind, the benefits of being in or on water. And so that's where the blue marble comes from. So for those who are interested in stormwater or environmental engineering, or just an interesting read, I do recommend his book called Blue Mind. So in that story, he accurately describes all the physical, ecological, economic, cognitive, emotional, psychological, physical, and social benefits of healthy oceans and waterways. And so if there's such a direct correlation between being, our personal and societal well-being of being on or near water, why would we ever want to bury the pond? Like, it just doesn't make sense, right? And so we're going to go through the why real quick. So as I always say, when starting, as we get to start with why, I'll say safety first. So that's where we'll start. As I said, I work predominantly on subsurface stormwater management. So everything I do gets buried. And a very large number of projects that I work on, say schools and things like that, the project that I'll work on might actually have the space for a surface pond, might have space for stormwater to be stored at the surface, but due to the potential for someone to get into that pond and find harm, they, and likely their insurance carrier, are not interested in having the pond at the surface on their property. Schools, childcare facilities, senior and memory care facilities. Even now I hear discussions from neighborhood associations that have concern over how much liability is shared by that neighborhood association, by the residents who all send their runoff into a regional pond in that neighborhood. That subdivision has a stormwater pond. Is a sign enough? If you put out signs, is that enough to protect yourself from the liability of someone finding harm in that pond? Do you have to fence it like a pool? How big of a fence? And does it need to be lit at night? I myself, and probably all of you that have any education in stormwater, I'm pretty grossed out about the thought of swimming in a stormwater pond. Like, ugh, gross. But I know with my toddler, I've got a he turns 2 next month. And if my toddler had wandered away out of my house and wandered to a pond, unless he is physically incapable of getting to the water's edge, he's going in. He's going to investigate. And so that just scares the living daylights out. In the same general vein of hazards that come from the fact that wet ponds and dry ponds, they're designed to and constructed really to mirror their natural sister systems. So they're designed to function like a natural pond. And so it should be no surprise that an animal likely does not know or care that it would be best if they didn't take up residence in the constructed pond versus the natural one out on the outskirts of town. So then, with those habitants such as mosquitoes, rats, and many other potential disease-ridden urban fauna that can bring a myriad of hazards and potential disease and contaminants along with their presence. Even in some urban areas, many airports require constructed stormwater systems to be underground, just because of the potential for bird strikes. So with those within a certain mile radius around some of those airport runways and terminals, all stormwater systems have to be underground. So there we go. So the next factor in our list of reasons to bury our ponds can be a bit more of a regional. And so according to USGS, water temperature plays an important, who's heard of USGS? Here we go, at least a few of you. Nice, all right, sweet. United States Geological Survey, water temperature plays an important role in almost all USGS water science. So water temperature exerts a major influence on biological activity and growth. It has effect on water chemistry. It can influence water quantity measurements, how the viscosity of water due to temperature, and governs the kind of organisms that can live in those water bodies. In natural environments, temperature is really not too much of a concern, as those aquatic species have evolved to be able to exist in those natural water bodies. It's when the temperature of that water body changes, either by a natural event or by some sort of human activity, that those fish start to break out in sweat and start to get a little bit worried. So our ponds, let's see, oh, there we go. Well, there we go. There's a photo of a nice steamy parking lot right after a summer rain. So our ponds are meant to accept, store, and treat rain as it comes off parking lots, just like this. So rain that falls on a parking lot that has, as that lot's been baking in the sun all day. And if you, for those who have tested asphalt, like I did through college, as I say, you can put your hand on asphalt up to about 125 degrees. And if you can't put your hand on it, you're north of 125 degrees. That water, anything that lands on that parking lot surface, that's hot. And so the water that falls on that parking lot gets superheated and then runs off into our ponds and streams. And if that water is not returned to a more normal temperature prior to entering natural downstream systems, that water can be a pretty severe shock to those aquatic life species. So taking that water underground first, even just temporarily, into a habitated, a place where animals aren't living, into a spot where they are not currently taking up residence, to allow it to cool off away from that flora and fauna can really significantly mitigate the risk of the heat shock. And then we'll say on the next of our list of reasons, I'm certainly not a real estate expert. When it came to purchasing a home, I will say I let my wife drive that far. So she's more of the specialist on that. But I think everyone has heard of the three most important things in real estate. It's right, location, location, and then location. The pictured example on the screen is of the the pictured example on the screen is of the church that I attended when I lived in Milwaukee. And when right here at the corner of First and North, St. Marcus Lutheran Church has been an incredibly successful school right in the Brewers Hill and Harambe neighborhoods. And if you ever look it up, those are some pretty gnarly neighborhoods as far as statistics go. All those statistics that you might look into for neighborhood metrics. It's not the prettiest of pictures, but through serious commitment and dedication, this school has continued to grow. But as part of that, they've been doing campus expansions, just like Platteville's doing a big giant expansion I got to tour last week. Awesome projects. And so St. Marcus was doing the same thing back in 2010. And the school was on the doorstep of breaking ground when the local city governing authority came in and said, if you continue to build this, you have to install some sort of stormwater management. You cannot continue to ride this grandfathered train of design and building without making some sort of change to your stormwater management. They were basically just sending it right into the combined sewers right off that front. And so after a few quick calculations, it became clear that the portion you see in front of you here on the screen, which is a very nice playground, would either have to be a pond or it would need to be a surface pond, or they would have to bury their stormwater under this playground. So everywhere else on that entire property is basically built, and there was no room left for anything else. So even though it was well before my time with ADS, I was able to track down construction. So right here, that is the stormwater system that's buried underneath. It's about halfway built. So those are the stormwater chambers that I work with now. So before my time with ADS, so it looks like this now, and that's what it looked like while it was still being built. So they weren't really given much of a choice. Bury their pond, move. They could move to a different facility, or limit their enrollment, which already to this day is still perpetually on a waiting list. So they really They weren't left with much of a choice. So all that stormwater got buried under their playground. And one of the more favorable items about many of these buried systems is the fact that many of them are made with post-consumer plastics. Both my products, there are several other ones out there. This, which anytime you can increase demand for those post-consumer plastics, it makes them more, as demand goes up, so will the price will follow. So right along those economic principles, if you guys take macroeconomics as part of your curriculum. No. Yeah, we took it at Valpo. I'm not sure it's a great class. I barely use it now. Anyway, but this massive demand increases the potential revenue to those municipalities that institute those recycling programs, which then, as the programs are better funded, they get better at their job. Those programs become better, which increases the quality and efficiency to keep those plastics out of landfills. So it all ends up, and so there's this myth out there you've ever heard, like, oh man, nobody buys those plastics anyway. It all just goes to the landfill anyway. Like, just so you know, like from where I sit, that's just not like within our company, we use 15,000 truckloads a year. And we can never find enough municipalities to buy from. So please recycle. It does not, it's not a waste. So my one public service now for the day. So yeah, the last time I sat in on the DNR's Council on Recycling meeting, where they talk about recycling trends across the state of Wisconsin, I actually saw where the price of number ones and number two plastics. So if you look at that little triangle with the number in the center, the price of number ones and number two plastics was more than that. So recycled aluminum was less expensive than recycled plastic. So at over $1 a pound. So your little 3-ounce soda jug is worth that in pennies. So at over $1 a pound. So there we go. The next one is a trend that's starting to pop up in the early adopter states with more robust stormwater programs. So that photo right there, that's taken in Minnesota. Many of the ponds that came through. So the reason we do stormwater at kind of a micro level, you've all heard of the Clean Water Act, I assume. Yeah, clean water. So, and the state of Wisconsin then is mandated by the Clean Water Act from the feds, from the EPA, to institute stormwater programs to clean up our rivers and streams. So as part of that, about 30 years ago, Minnesota was one of the first early adopters of the Clean Water Act. Minnesota has some of the oldest ponds in the country. And so and many of these ponds have long since reached their maintenance cycle, where 30 years is about the life cycle of a pond that's been designed properly. And so as they reach their maintenance cycle, they've really ceased to do their job. They're not really functioning anymore. So as these systems are beginning to get the attention they deserve, they're finding out how much it costs to do that stormwater cleaning. So and with that comes some pretty significant sticker shock. So the article on the screen, a colleague of mine out of Minnesota sent me a few articles that were just hitting newsstands right before the pandemic. And once the pandemic hit, basically anything that was newsworthy before just was. So the cost of dredging and disposal of the sediment in the ponds around this municipality right here in the Twin Cities area was the cost of the sediment, the disposal of the sediment in the ponds around this municipality due to the nefarious nature of the chemicals used in parking lot and driveway sealants, actually used over many years, that made its way into the city's MS4 ponds. So the city was maintaining the ponds, that was treating the runoff from all these parking lots that had used coal tar sealants. The sealants contain high concentrations of polycyclic aromatic hydrocarbons. Now PFAS is the one you hear about all the time, but PAHs, polycyclic aromatic hydrocarbons, which harm fish and pose a risk to cancer in humans, of course. So significant concentrations of PAHs. USGS has found that coal tar sealants account for about half of the hazardous PAHs found in 40 lakes sampled across the country. So USGS has got it on their radar too. The PAHs are pretty much everywhere. The pond did its job. the pond removed the pollutants, like those pollutants settled out in that stormwater pond, just like they were designed to. But now you got to do something with it. Like as those sediments get cleaned out, you got to take them somewhere. So just the cost to haul the sediment to the landfill for proper disposal can be over $150,000 per pond, depending on the size and concentration that has built up over the course of decades. When the city of Inver Grove Heights tested 10 ponds in 2019, it found out of those 10 ponds, it found 2 with unsafe levels. So the cost to clean up just one of those, which had 7,000 cubic yards of contaminated sediment, was estimated at almost $500,000. So suddenly the stormwater cost bankrupt the town, which is just some nasty sticker shock. So hold on. Yeah. Any questions up to this point? Let me just pause right there. I went through a lot of information. Stormwater students in the room. Do you like declare an emphasis, a focus? Environmental emphasis. Okay, cool. Sweet. Right. So I'll actually go through a quick cost comparison of underground system maintenance versus surface level stormwater pond maintenance. So on your screen, based on the chart, yeah, I've got. I'm just gonna skip that. So it's at this point when we start to transition really out of the why. So we covered why we might want to bury the pond. Now let's get into how. So and depending on whether you're, if you're talking with a developer, an engineer, a regulator that's got oversight, or any, you might be asking yourself, what if I already have it? What if I've, and I'm not quite ready to turn my property into a construction zone yet? I already own my pond. What do I do now? I will say that many municipalities have begun to retrofit some of their ponds with upstream pretreatment. Actually, on my way in the building, there's a catch basin right outside with a coarse settling device built into that manhole. So there's a pollutant removal device right inside the unit, right outside the engineering building. So at the last catch basin or manhole, prior to a pond, just like the one outside, they install a much more effective water quality unit to keep a lot of that sediment from ever reaching the pond wall. So it allows you to clean out your manholes and catch basins on a fairly regular basis, and then you get that ounce of prevention versus that pound of cure. So these units typically have much easier access for regular scheduled maintenance and cleaning, and much more minor disposal costs without having to do like a full pond dewatering. So if you've ever seen how a pond gets cleaned out, they basically empty the entire pond of the water, and they pump all that water through big filter bags. And then once all the water's through the filter bag, there's a bunch of dirt left in that bag, and they have to haul all that dirt off, all that sediment, trash, leaves, decaying animals, all kinds of things. So, and so that is a significant cost. So if you can mitigate the number of times that might happen, the one on your screen, this is a pre-treatment unit, and really shows how dirty stormwater is. Like stormwater is gross, guys. If you didn't know, we get it in such concentrations we don't realize. So this one happens to be from a company called Hydra International, and the model on your screen is called a downstream defender. And so what the swirl separator units do, they actually, the downstream defender is usually in a 4, 6, 8 foot diameter manhole. And what it does is the inlet and outlet configuration, the water comes in from the outside and enters the manhole so that it starts swirling inside. So with the swirling action that's happening inside that manhole, the water's in there longer, which allows for more sedimentation. So the water can drop out, or the sediments can drop out of that water by being in that unit longer. And then on top of that, it's got like an internal cone that keeps floatables from discharging from the unit as well. So really just a pollutant removal device that they can install right in front of that, right in front of you. So pre-treatment systems typically targeting the pollutants somewhere in the 50 micron range and above. So I don't know if you guys do much in the way of environmental design that way with water quality units. Most of the targeted pollutant loads here in this country are targeting between 50 and 100. Wisconsin's a little weird in that our pollutant load that we're targeting is about 10 microns. And to give you some idea, we're targeting pollutants that are about a third of the size of a grain of flour. So Wisconsin standards are unlike anywhere else in the country. So you know. So if you're able to add that for add that to your upstream storm sewer costs and eliminate one dredging and disposal, even with regular cleaning costs, the overall savings in the life cycle of a BMP can be pretty significant. So where all of a sudden you see right here, this blue line is the cost of ownership for a pond. So even though nothing cheaper than digging a hole in the ground and putting water in it, once you have to do it again, about 15, 20, 30 years later, suddenly the cost of that can be pretty significant. Rather than that little bit of maintenance costs, you get a lot of initial cost in the building of that stormwater system, but a lot of times by the time you reach the 30-year life cycle, the 50-year life cycle, those costs have leveled. So just a different way to think about it. So, and while we're on that subject, we'll talk a little bit about what maintenance might look like on an underground system. So once those pollutants are contained within an underground pond, a lot of those get cleaned out with a jet vac process. So this right here, forgive me how old this video is. There's not a lot of my systems that have reached their design life cycle for maintenance and aren't old enough yet to need to be cleaned. And so this is the one that I've got. So, but as you can see, the jet vac actually goes into a stormwater system. All this sediment's built up on the bottom. All that gets jetted back to a clean out structure on the end of that stormwater system. So this is an underground stormwater storage and treatment system, and also promotes infiltration. So there's an underground chamber system, just like you saw at that church project. We'll go into some different project examples here closer to the end. And then this right here, also further illustrating how dirty stormwater is. Any construction management students in the room? Any CM students? Right, nice. So this stormwater system went live. So they basically hooked up all their storm sewer during construction to their post-construction stormwater devices. So during construction, you use like inlet protections, silt fence, all that stuff you see around the engineering building right now for erosion control. They didn't have any of that in. They just sent it to this system. And since this removes sediment, removes pollutants, it did its job, but it also saw about 20 years worth of sediment in about 6 months. And so before the owner was willing to take ownership of the stormwater system, they asked the contractor, like, that's great. You actually need to go clean that out before it becomes ours. And so hence the jet vac. This is that hose right here. This is the back truck hose, and all that sediment's being washed out of their stormwater system just to get vacuumed out. So pretty disgusting. That project, I'll say that one wasn't broken. It was over in Ohio. So the one thing that I will say about underground stormwater systems, similar to this coal miner who spends his days up to his safety glasses and up to his safety glasses in filth to deliver coal power to our energy grid, subsurface stormwater is grinding it out unseen, doing all of its job, doing all of its work underground, unknown by pretty much anyone that comes near it. Which brings me to what I would say is the one pitfall of underground stormwater management. I have the 3 classic pillars of sustainability on the screen. You probably have all heard of this, like the whole sustainability. Yeah. So especially with ASCE now coming out with a sustainable design manual, the ASCE, I think it's 144. ASCE 7 is for like structure. Yeah. Anyway, when it comes to the first 2 pillars, most subsurface systems do shine. It makes good environmental sense, makes pretty good economic sense, especially when you consider the cost of real estate. But it's difficult to have much in the way of a social interaction and a social awareness, let alone impact, when the system is completely out of sight and likely out of mind. So in my career so far with ADS, I have only ever seen one sign placed at the surface that shows what's buried under. And I think that's a shame. And so that's one, and it's a Milwaukee County project right over by Veterans Park. So there's a signboard at it's McKinley Beach has a storm tech system buried underneath it, and because of the sign, you know it's there. Otherwise, you would never know it's there. And so that's why it's important that for me as an industry professional, and for you all as future industry professionals, that I do engage with my community and talk about what happens when stormwater goes underground. So like my wife gets tired of my stories, but like it's actually important that I talk about what I do, because when it comes down to it, like folks might think twice about their impact on the environment when they know that underground something out there is paying with their spent dollars, or commercially or tax dollars that are spent to take care of our messes. So we might just be less likely to send something, to dump something where it's not supposed to be, to litter, or to manage our grass clippings poorly when we're mowing our lawns, like when all that stuff gets sent out in the street. Like, and you got to pay for somebody to take care of that. Like, yeah, it goes down the storm drain and it's out of your hair, but like, it's still not really out of your hair. You're just paying for someone else to make it. So, so it's all about awareness in that regard. Which kind of brings me to my last two parts. A few examples, and then we might go through a couple of design. But I will take this opportunity to reiterate and disclose that I do have a financial incentive towards buried stormwater systems. Obviously, that's clear. I'm pretty enthusiastic about it myself. I am paid by a manufacturer that produces construction materials for that exact application. So please understand that there are many companies out there that also produce proprietary products that can be used for this application. The overwhelming majority of underground stormwater systems are proprietary devices, just by nature of what they what it's trying to do. That it's finding a way to structurally bury your pond under some sort of much more usable infrastructure. So fortunately, most of these systems can be specified with non-proprietary specifications. So when you're writing specifications for, say, public projects that are funded by tax dollars, there are ways that you can specify those proprietary systems with non-proprietary specifications. So it's all about how you write those specs. So I'm going to play that one more time. So this right here, that stormwater system is installed at a hotel. That's the we'll not say that, but right in Lake Delton, restaurant hotel site where they actually needed stormwater storage for treatment and detention and rate control. So they needed to hold that water back. And so right under their parking lot, and actually the interesting part about this one, if you see along that left edge, there's a pretty big retaining wall. So storing your stormwater right next to a retaining wall is a pretty bold move too. So that one actually had a full impermeable liner around the bottom of it, because that stormwater system is open bottom. So we use the storage in the rock as well as the storage inside that underground chamber for that system for storm tech. So we had to do a full impermeable liner on that to mitigate risk to the retaining. So neat project, and construction always looks better from a drone than it does from down at the surface. So it also helped too that contractor was really clean and really professional. So I'll give a shout out to that contractor as well. Some other, as I say, there are some good stormwater systems out there. There are some not so good ones. The one on the screen right there, the one picture right here is called Storm Trap. So the one that I work with is called Storm Tech. I know, not confusing at all. So Storm Tech is from ADS. It's an underground thermoplastic chamber system. Storm Trap, as you can see on your screen, is actually made of precast concrete. So it's basically like a precast. It's basically like building a basement, and then you can send stormwater. So concrete vaults with modular systems that can be configured to meet some of the most challenging urban projects. We see a lot of this product line down in Chicago, because a lot of times you're not really supposed to put stormwater systems under the footprint of a building with like permanent occupancy. So if there's residential units, they're not really supposed to put it directly under that. So they try and find a spot, say in parking lots or parks or playgrounds, where they can put those stormwater systems. But it just kind of looks wild, right? Like where someone messed up and flooded their basement. Is what this looks like. So Storm Trap's a good product. I know their local Midwestern rep really well, and that's a good friend of mine. So he and I get along real well. Another system that we see a lot of, depending on what part of the country you're located in, it's often referred to as a crate system. So if you look real close, they're called crate systems. I believe it's due to their similar look to an actual milk crate. So right there, going after the hearts and minds of the dairy state with milk crates. These modular interlocking crates, typically made of high density polyethylene, just like a lot of the products that my company works with, and which is again a benefit. They can use recycled material as well, so they can use recycled thermoplastics to provide storage volume needed to meet those detention requirements as part of their stormwater. There you go, and my favorite one of the more interesting ones that's popped up on an occasion. It's just starting to get some momentum. Is projects all over the country from a company called Green Blue. And most urban trees, the trees that you see planted in downtown areas, they're planted in a box that's usually what, maybe 5-6 feet square, which is really like a little tree coffin, like where that tree is going to grow and it's going to provide this really nice canopy, but it's going to be root bound in maybe a decade. And at that point, it's going to just limp through and probably die. And so this Green Blue has developed a structurally viable way to create space for a much larger and more healthy root ball without compromising, without risking major damage to the surrounding infrastructure. So right in the middle of your downtown streets, they've created a crate system that allows for loose soils under the road, which then gives room for those root balls to expand. At that point, like the amount of benefits from a tree versus, like, say, green infrastructure with small shrubs, small shrubs that you see in like a rain garden or a biofilter. Trees are workhorses. Like you get stormwater uptake through the root systems, you get evapotranspiration from the water that's on the leaves, you get CO2 usage in much greater quantities. And and there's probably more that I'm forgetting. But a really neat product that my company does. So but with good autumn leaf management, especially as the leaves fall, you don't want those leaves to then create a phosphorus, concentrated phosphorus load downstream. I can't imagine how these devices won't do good things in dense urban settings. So it mitigates temperature, like you get a cooler downtown because you're in the shade. Like there's just a neat product. I enjoy talking about some of the ones that are more exciting. Many times these and other underground systems do require a lot of ancillary treatment. So like there's really neat ways that you can combine all sorts of systems together in order to provide more sedimentation in a treatment train approach. So the water quality provided by the energy dissipation from permeable paver systems, and it causes those pollutants to settle out, can be matched with all kinds of options, each with their different costs and associated performance. Anything from, say, the hydrodynamic separator, the swirl separator that you saw earlier, to the prefabricated green infrastructure units like the one on the screen. So on the left-hand side of that screen, the Eco Pure biofilter, that one is made by ADS. It's a pre-manufactured green infrastructure unit. So it's got a core settling screen on the right-hand side, and then a water conveyance system where the water actually percolates up from the bottom into the root ball system of the green infrastructure. So a neat product there. We just came out with that during the pandemic. So not a great time to roll out a new product, but nonetheless, it does do its job. And then I've also had the opportunity and the fun experience of working with permeable paver manufacturers from companies like Pave Drain, where they take permeable paver blocks and we'll actually use those as how water gets into our storm tank chamber system. So like underground chamber systems with a permeable paver block at the top, at that point you don't need storm sewer to get into the system. Like it mitigates a lot of costs that way, but you also get the pre-treatment and some of the flow attenuation from the permeable paver blocks at the surface. So neat design methodologies, and why we all kind of have to get along together as manufacturers, because we might only have a portion of the project that comes from our employers. So like we kind of have to partner with our competitors all the time. So an interesting. So yeah, and same with combination systems with bioretention, biofiltration, more of your classic green infrastructure. So this example on your screen there, you see right here. So I'm going to go through an example project. Here we go. So one of my favorite example projects across the state, down in anyone from Southeast Wisconsin, near like Delafield, Commonwealth. Yeah, sweet. So there is a small restaurant with a red label. They make sandwiches with chicken. That's probably the end of it. So right near the Highway 83 exit, this was the parcel prior to construction where the dry pond for the entire rest of the 14-acre development was being stored in this last parcel. And so that restaurant really wanted to build right here. And so normally a restaurant that size gets about a 2-acre property, and we'll say they need a stormwater management system this size. But because this parcel was where they were storing the stormwater for the entire rest of the development, they needed a stormwater system this size. And so the underneath, here we go. There's an aerial footage of that system going in the ground. So you can see that the excavator on the left-hand side, just to kind of get a perspective on how big that system is. And so right underneath that pond, they had to bury that pond. It was taking almost the entire parking lot. So the entire surface of that entire parcel. If it wasn't the building, it was stormwater storage. So right under there. So despite their stormwater cost being about 10 times what a normal, chicken sandwich restaurant would need, it was the only way that they were going to be able to build on that spot. And so fortunately for them, it's in such a location that you can see it from Interstate 94 in time to take the exit. So as long as you go on any day but Sunday, you can then get your fix. Inevitably for me, I always forget. I always end up pulling into that place on Sunday. So I will say that it is one of my favorite clients to work with, to give you all a confidence to shop at those locations. The chicken sandwich maker is one of my favorite developers. Yeah. For sure.
Okay, I know exactly.
Yep, for sure.
I live right by it.
Yeah. And so yeah, you'd never know that that's buried underneath the parking lot. And what's really nice about that owner and that owner nationally as well, is they really do want to do the right thing as far as their stormwater management systems go. They do want to do good maintenance and operation. They don't really care what it costs. They're going to do regular cleaning. They're going to do regular maintenance. They're going to spend the money to do their environmental stewardship right. So not every developer, every owner you're going to run into is that way. So it's really refreshing when one of them, even one as big as that one, really gets it. So other ones in that same genre, large warehouse that sells the curtain stuff. That's not really all that anonymous. Sorry. But yeah. So oh shoot, yeah. Whoops. Yeah, that was nice. So the other last kind of underground device that I'm gonna talk about real quick, and projects that I've gotten to work on a little bit, rainwater cisterns. So anybody heard of rainwater harvesting? You're taking that rainwater? Yeah, for sure. So a trend that I'm starting to see a little bit more of here in Wisconsin. There we go. So our pipe and chamber systems are used for storage. But then what's really neat is some owners, if they're smart, they're able to institute rainwater harvesting into their development, into their project. So right here, and I don't mind saying who this was. This was at the new Komatsu facility in Milwaukee. So they were taking their roof water, rainwater, stormwater from the surface, rainwater from the water. So if anyone ever asked you the difference between those two, stormwater comes from everything that's not. Rainwater is considered, so it's cleaner, it's less pollutants to remove, But they are taking their rainwater and they are running it back into the building for their plumbing system. So back into the toilets. So it goes from the roof into a tank, similar to that one. And then from there, it goes into the building. And so you can't quite see the filtration system. So over here on the left-hand side, you can see that small screen over his right shoulder guy in that photo. That's the control unit. So water comes in from there. It goes through a swirl separator outside. So one of our swirl separator units that basically grabs the really big stuff that might try and get in there. And then it goes through a coarse settling screen, another finer filtration device, one more filtration device, and then it goes through a UV light, and then it goes through a chlorination system. So that chlorination system right there, that tank with the bluish liquid in there, that's chlorine. So at that point, we're pretty much, and then it goes into a day tank. So there's a big tank outside, goes through all those treatment systems into the day tank there, and then gets pumped out into the toilets. And some of you might ask, like, wow, chlorine, like that's almost drinkable at that point. Why would you ever send drinkable? Like, are they anticipating someone's going to drink from the toilet? And I asked that same question, and I felt really stupid because they look back and it's actually about the smell. So if they don't chlorinate it prior to entering the plumbing systems, no matter how clean it is, when you walk in the bathroom, it smells like bacteria. It does, it's a perception. So it's really about the cleanliness. So just some neat projects to get to work on. And what's really interesting is I realized how expensive they are. Matsu did this kind of their own. They were not required to do rainwater harvesting as part of their project. So this is say $250,000 system that they did just to do the right thing. But sometimes they can downsize their laterals from the water mains, the laterals from the mains coming off there. And as soon as you downsize that lateral, a lot of times that can almost balance out the entire cost of the system. So just an interesting economics of why someone might do some of these projects. I've seen a lot of breweries looking into it for wort chillers. So like Third Space Brewing, Mobcraft Brewing in Milwaukee, also looking at using rainwater harvesting to use for their wort chillers. So as they're making beer, they're going to use rainwater to cool off that beer so that they can add the yeast without killing the yeast. Anyone here at home brewer? That's not probably old enough. Anyway, stop mumbling. So, and here's an aerial footage of what some of those rainwater harvesting systems might look like. This one didn't end up finding enough of a use of the rainwater to pump it back into the building. So they ended up just using that pipe system, that cistern as a water quality device. There's a permanent pool that stays inside those pipes to allow for sedimentation. But that's kind of what it would look from an aerial point of view on what those cistern systems might look like. So just the black corrugated plastic pipe there, that's kind of my company's flagship product, used for a wide variety of different applications, anywhere from stormwater conveyance and storage to tough mudder obstacles. So with that, I'll jump into a summary. So ponds, when they're healthier, are awesome. They're terrible when they're not. Underground systems can be a great option, and I work with them all over the state. It's a neat thing to do that I never thought I would do when I graduated from Valpo. But with that, I'll open it up for questions. My role for here in Wisconsin is I work with a lot of consultants and future consultants just like yourself to do education sessions just like this for continuing education, growing, and keeping your licensure up. So who's taking the FE already? And then do you guys get to take the PE before you graduate now? Is that a thing?
No.
Yeah, I didn't get to do that. I had to wait. I would have much rather taken it when I was still a student. But yeah, so and especially with my role across the state of Wisconsin, I interact with just about every engineer on the planet. Delta 3 right out of here at Platteville, I work with those guys on a pretty regular basis. And so if they have their office in Wisconsin, if they do projects in Wisconsin, they've likely had to reach out to me at some point, but even just an offhand question about products that we make and their acceptable uses. So if you guys are looking at different companies and would like an unbiased opinion on them, there's my name and phone number. Questions?
What's one of the most with the underground one? What are like the main confining factors, or what are some unique ones that you've ran into that are out of the ordinary besides can go over time?
Great question. So the biggest things we look for, one, we can't go too deep and get close to the water table, especially because the systems I work with, they promote infiltration. And so if you're right up against the water table, one of two things is going to happen. One, the water table comes up into your system, and then you're basically siphoning off the water table downstream. So you become like this pump system, like that sends the water table into your rivers and streams, which it'll make it there eventually. You just don't want it to happen that fast. Or two, you have the potential that some contaminants could get into the water. So you like a little bit of native soils to act as a filter prior to that water getting into the water table, so that you don't end up with those pollutants in, say, a well. And so those are probably between that and then anytime we bump up against where our systems end up in fire lanes, there's some interesting structural calculations for fire trucks with outriggers. Fire trucks don't like publishing their outrigger loads, so it's always a challenge to just kind of throw a dart and assume that our subsurface stormwater systems are going to hold up those loads once they throw those outriggers out and down. Like I wish you guys would tell us how much those weigh. And because once you put your outriggers out and down, then you're boomed out with whatever fire equipment, like you don't know what that torque load might be out on that outrigger, and you hope all of a sudden it just doesn't go pop and drop your ground stormwater systems down. So those can be some of the more tricky and challenging ones. Anytime there's contaminated soils, there's a new art museum up in De Pere that's getting one of our systems, and we initially went in with an underground chamber system, with the big giant yellow one, and then we realized how contaminated the soils were on that site, and so we ended up having to switch that to a full watertight system, and with a big giant, basically an oversized Brita filter. So we have a media filter called an upflow filter that we work with, and so they got their water quality from the industrial sized Brita, and then their stormwater storage was in a watertight pipe, because every single cubic yard of excavation was very expensive. Like normally it's about a dollar a cubic yard for excavation, and all off it was like 10 times that for their contaminated soils on their site. And on the same project, they had thermal injection, their HVAC units. They were getting their well field where they drilled down to get. Thank you, geothermal wells at like 6 feet on center, like right over the top of our stormwater system. So like the amount of detail on our design for that had to be pretty sophisticated. Like normally when you're building one of our systems, we're not exactly building like it'll work as long as you don't do something really unwise. But like when all of a sudden you might hit a geothermal well, or your geothermal well goes right through your stormwater system. Suddenly that stinks for everybody. So yeah, those are some of the more interesting ones. And anytime we're working on high profile projects like the new Rush Center right in the shadows of Rainbow Field, the new Green Bay Convention Center's got a giant stormwater system. That one was put in about 2 years ago. Yeah, neat project. Just to, and it's really hard to point to the work that I do because it all gets buried. So like I never have to go, like honestly, I drove around Platteville a week ago because we were here to tour your construction management facilities, which are awesome, by the way, neat programs, and tour the new constructed facilities over on the other side of campus. And like I'm like, oh, there's one of my systems under there. Oh, one under there too. Like, and so it's just I do about 2 or 3 designs a day, just in Wisconsin projects. So it's not hard to imagine in any decent sized metro area. I never have to look very hard to find one of my projects. Good question. Yeah.
How does that underground system handle like a larger storm event, or with a detention pond, you've got a pond, like a big wide safety zone? Yeah,
you've got basically that freeboard, right? So in a normal pond, your depth to your you've got a segmented outlet. So on one of our systems, basically the system is supposed to be empty at the beginning of the rain event. And so normally to convey the 100-year storm event, you might need, say, a 24-inch pipe. And so detention, you're going to actually try and attenuate that down to, for a 1-year storm, you're going to try and outlet that and say a 3 or 4-inch pipe, 3 or 4-inch diameter orifice in a control system. And then above that at a higher elevation, once that system gets a little higher, you're going to then transition to, say, a 10-inch diameter pipe. And then once you get fully full, the control system will have a weir that it overflows. So as you're trying to neck those flows down, say 24-inch flow going into a 4-inch flow, just like a bladder, you got to have somewhere to put that water, at least temporarily. So you have to have all that storage ready to go. So the storm tech system is basically an empty bladder that temporarily stores that storm water. And for most projects here in Wisconsin, we're storing the 100-year event. Interesting one from Madison. Madison, due to their bad experience in 2018, if you all saw the 3 feet of water standing in Costco in the city of Middleton, they now have to account for a safe overland flow. So they don't have to store the 500-year rain event, but they do have to know where it's going to go on their property. So as you figure out, if your parking lot's completely full of water because the 500-year event is in town, where's that water going to go? And so just some neat things happening just because we're realizing how undersized our systems really are. The 100-year events have been happening about every 2 or 3 years. So not exactly a 100-year return on those stormwater peak events. And so designing for those 100-year events. Good question.
I was just curious, 2 summers ago, I was actually on site where we put in an ADS system.
Oh, God.
And
okay.
So just it was really cool to see. And one of the things we ran into is we had a perk test.
Sure.
And it ended up going a little too fast based on whatever the watershed.
Yeah.
And so they had to mix in some stuff with the soil, try to slow it down before it hit the water table.
Sure.
And so I was just curious, as you're designing, do you take in soil borings or anything like that ever? Does that come into play, or is it more just figure out what's there when you install it?
A lot of times the borings are accurate. And we've even seen some regulators accept a GIS map of soil types where they assume GIS is accurate. I think that's a little bold in my opinion. I think, to some extent you really need, because the test pits are probably as good as you're going to get. But even test pits, once you dig down, you're smearing a lot of soils. Any geotech investigation on stormwater is going to be tricky. And that's why a lot of those infiltration rates that we get from those studies, a lot of them are really conservative. So with something like that, it shouldn't be all that surprising that the actual infiltration rate ended up being much higher. And so that's one of the things too. At that point, they're worried about contamination of groundwater. They want to add in some fines that's going to act as a natural filter.
Yep.
Where was that?
What's that?
Where was that project?
St. Cloud, Minnesota.
So that would have been in my territory. Yep, would have been. Yeah. So, and Minnesota, a lot of times too, they'll actually add in a 6-inch layer of sand under all systems.
Okay.
Yeah, and that's that St. Anthony Falls Laboratory in Minnesota is a little weird. One of my professors that's where he spends his sabbaticals. And they got some weird stuff up there, like the iron enhanced sand filters out of Minnesota. So, yep, great question.
All right, I'll do this. It's already 6:04.
Yeah.
So I know some of you have other things to do. So first I'm gonna officially close it, so you don't feel awkward to leave if you have things to do. But I know the speaker will be here and then answer questions. We have questions coming up from online too. So feel free to stay and then feel free to leave as well. So how about that? And then also here, I want to give a very small gift that I'm glad on behalf of the students at UW-Platteville. Thank you very much for coming.
No, thank you for having me.
Yeah, so then we'll still continue the discussion, okay? Feel free to leave too, if you have something to do.
Thank you.
Does APS design offer systems for residential users, rainwater for irrigation use on their property? If so, use information on your website.
Yes. So cistern systems for residential users. Oh, we do, yeah, for sure. Most of our cistern systems end up on commercial properties, but there's no reason we couldn't do it for residential too. So whoever asked that question from, it's Roselle's Danny. Oh, Jason Rose, I didn't realize those guys were in here. Let's see. Yeah, from Brent Schuster. Good question, Brent. We do. And so, you can honestly reach out to my contact information on the screen. Happy to help with that.
There's one Nora, you can do that. Nora's first, there's, it's hard to, the Lake Durton, the Lake Durton.
Oh, Laura Spears, the Lake Delton project. You should. Yes, that would be La Quinta. Correct. That would be the La Quinta Inn right in Lake Delton. Oh, jeez. All right.
I think that,
I think that was it. There's Megan McCarthy.
yeah, you guys have any other questions?
I just find it interesting that we've progressed over the last 100 years with this putting in systems again.
I know, right? No, honestly, a buddy of mine that lives in Fond du Lac just bought his house, like a turn of the century. And he was showing me his new house. I mean, so I get downstairs in the basement and he's like, oh, there's my cistern. I gotta get that thing out of here. I'm not using that. I'm like, dude, do you know how much people spend to get one of those now? It's like, do you know how expensive that is? Now, granted, it was just like downspouts into his basement, which like in a 100-year-old house, maybe not a great idea, but like nonetheless, like at that time, that's sustainability at its core.
I'm down in Northwest Illinois, so a lot of ours are all brick. Generally, they're a full circle, you know.
And they probably leak like sieves.
And no, they do not.
Really?
They're watertight because they're system.
Oh,
So
sure.
you're pulling all your roof drains in there.
Yeah, for sure.
And then there's a pipe that runs back into the house, they pump it into running water.
Yeah.
So it's kind of.
Yeah. And so there's so many regulations around it now, which is why it's obviously a lot more. But neat. Anytime I get to work on marine water harvest, it's gonna be a project. I'm always gonna learn a ton. Just because it's one of those